Hi guys, BuildZoid here, and today we're going to be doing some more RAM overclocking. This time on a very, very cheap memory kit. So this right here is a Vengeance LPX stick that I picked up on eBay. As you can see, it's version 3.22. It's also 2400 CL14 at 1.2 volts. So this is very, very low XMP. Like the XMP spec on this is really, really low. It uses an A2 PCB, which is a good thing because my goals are to go high frequency with it. So actually, yeah, so you can see all the memory chips in the group, the two groups on both sides of the memory stick, right? So, or, well, kinda, yeah, there you can see them. So it's an A2 PCB layout, which just means that you have a group of memory chips over, like the memory chips are in two groups on either end of the stick, right? So, which I'm doing a terrible job of demonstrating that, but I've had other videos where I cover that and you can check those out. So anyway, yeah, we're gonna use a Z490 Vision G from Gigabyte. Mostly because that's just whatever motherboard I have on my desk right now. We're gonna see how far I can push these. So the version number 3.22 tells us that this is definitely Micron, and it's 4 gigabit Micron, so this is a single rank memory stick, which really shouldn't surprise you considering it's a 4 gig stick. Like, you can technically get dual rank 8 gig sticks, but they're generally, like, they're old. They're not new, because in the past you couldn't get 8 gigabit ICs, and so you do dual rank like 8 gig sticks in dual rank, which I've been kind of toying with the idea of maybe picking up one of those kinds of sticks, but they're also like not really relevant anymore because you can't buy them anywhere else except eBay, which is like buying memory sticks off of eBay it's like no, I wouldn't highly recommend it unless you are like a memory collector and you know you're willing to put up with all kinds of annoyances. So anyway, yeah, let's see what this does. Let's clear the Cmos on this board first. And troubleshooting LEDs. Oh, you might not be able to see them. So there. Now you can see them. And yeah, we'll see how far this goes. So it is on an A2 PCB, so assuming that the memory chips on there are capable of going, well, if the memory chips can clock high, the stick, like the PCB won't stop them. If we were on an A0 PCB, there's like a hard wall at 4666-ish. Damn it, let it go into Windows. Oh boy. Also, fun fact, 2400 CL14 is XMP, because that's not an official JEDEC spec. So, also this operating system isn't like, is gonna have to figure out the GPU. This is what I get for doing a video with absolutely no prep. Let me change the resolution. We're gonna go into Windows later, so I'm just gonna take care of this right now. Why? No GPU go away, thank you. Oh. Windows, why are you so stupid all the time? Oh, it's just not gonna let us. Okay, well, the driver, like, anyway. Guess while we're waiting for that, where's CPU-Z? Oh, well, that's great question. Where is it? Oh, it's over. Oh, no. Oh, no. Yeah, okay, well, this is a disaster. Desktop, yay. Okay, now we can use the... I'm just going to pull up CPU-Z. See if it can pull any useful information from the SPD. Can, so Corsair, Micron, yeah, because it's version 3.2. It's single rank memory sticks, of course. Yeah, and so here you have the JEDEC settings, right? Like 2133. So that's what it'll default to right now. And then there's a 2400 CL14 XMP, which is like, so if you don't enable the XMP, this just runs like this, which is not great. But yeah, that's pretty normal. Like even high-end kits will default to 213315 a lot of the time. Now I'm kind of wondering if the NVIDIA driver has figured out what GPU I have plugged in. I don't think it has. Anyway, we're just going to restart and hope that the resolution comes back. Worst case scenario, we're just going to have to put up with Windows being at, what is it, like 1024 by 768, which I don't think I've ever seen, like, well, anyway, very low resolution. Also, yeah, so this board is a bit special in that, I mean, the board has like this whole white theme going on, and Gigabyte's shoved that into the BIOS. So, I mean, I personally don't find it a problem, but yeah, you might find it kind of annoying. So we're not going to do anything to the CPU just yet. We're just going to mess with the memory. So we're going to start with the Xmp profile, see what that does. I mean, I don't really expect it to do much, but yeah, like the Xmp, hopefully at least the Xmp works, right? Right? Okay, it does. This is the thing with not having a postcode is like it's not very easy to tell if the memory, like if the system is booting. So, or it's not as easy to tell like what the system is doing. Anyway, we're going to go to 1.3 volts. Now we're going to start at 1.3 volts because I have no idea how these memory chips behave whatsoever. I've never worked with these. So the thing is, there's quite a few memory chips where once you go above like 1.35, they actually get worse. So you don't just want to go straight to 1.5 volts if you're working with a memory chip that you've never worked with before, because for all you know, it really hates high voltage. So we're going to start at 1.3, which should still be perfectly fine. And then we're going to go into the advanced memory settings, and we're not actually going to benchmark this XMP because that's dumb. I don't need to benchmark this to know that it's going to be really slow. And we're just going to start with a bunch of really loose timings because I want to see how high we can push the frequency with like terrible timings. So it's the first thing I want to see. So we're going to go 18, 24, 24. Potentially, like, depending on, honestly, even like 22, 28, like if we hit a wall, we might go up to something like that. At the same time, it's not a good idea to immediately jump to like super high latencies, because there are certain memory chips where if you punch in like cast latency 26, it just won't turn on. Like, it just won't post because that's not a supported timing for those. So you want to start out at something like 18, because yeah, like all the way up to basically up to 22, it has to be supported because 3200 CL22 is actually a JEDEC specification. I think even 24 is technically a JEDEC specification. So there are like loose timings that are functional, but you don't want to go too high. And so we're going to start with 1824 initially at 1.3 volts. And I don't know, let's just go to 3200 right off the bat. Like, I'm assuming this is going to work. I don't know if the motherboard's very, like, how the compatibility is with these chips and Z490 motherboards, so, you know, this might not work at all. And, okay, it still works, so yeah, bam. Right? Like, you really, like, 3200 is not difficult, which is why I don't like 3200 CL16 memory kits. I mean, this is 3218, but I would be very surprised if we couldn't tighten it up to 3216, which is why 3216, in my opinion, is not a very good bin, because everything does that. Well, almost everything. There was a time when 3200 was difficult, but now is not that time anymore. So we're going to go, yeah, we're just going to go... Yeah, I'm just going to whack these kind of unnecessarily high. These are both still completely safe voltages for both the I/O and the system agent. And they're not necessary until you get into well over 4,000 megahertz, but I'm lazy and I don't feel like readjusting them later on. So we're just going to go straight to 1.3 right off the bat. Let's see if 3600 works. Okay, it seems to be kind of upset now. Very upset. Yeah, I don't think that's going to work. Oh, well. That would have been a bit too easy if it just worked. So we're going to try the same thing, but with more voltage. Also, I'm not going to bother with enabling the XMP this time. Though that is something you might want to play around with depending on your motherboard. On some motherboards, having the XMP enabled helps with memory compatibility, and so the overclocking range improves, but on other motherboards it doesn't make a difference, and or actually it can sometimes make things worse. So this time we're going to do 3218 with 1.4, and then we're going to go to 3600 with, well, 3600, 18 with 1.4. So we're just going to go back in. Going to go straight to 3200. I'm actually going to loosen up a couple more timings. Also, I'm going to set the VCCIO and SA at 1.3 at the same time, just in case that... Because that might have been the... Like, that might have upset the memory controller for some reason. It shouldn't, but, like, with memory overclocking, it's just like... You kind of never know. For sure, that's something that you did that doesn't seem like it should cause any issues... unexpectedly causes issues. So we're going to go to 24 again, 48. And this time, one thing I want to try is I'm going to actually loosen the TRFC. This is bad for performance, but I just want to see what kind of frequencies these memory chips are capable of doing. We're also going to set the command rate to 2T, which this just, again, helps with stability. It's not good for performance, but, you know, that's not my priority here. I just want frequencies. We're also going to go to TCWL 18. Okay. Okay, now that boots. It's with 1.4, so now we're going to try 3466. Not going to skip all the way to 3600 this time. Okay, that works. I mean, you know, a 1 gigahertz, like this is more than a gigahertz over stock, so that's not really bad, you know? It's not a bad overclock already, but I'm not done. I'm not even close to done. Need to go faster. I'm gonna try 2026. Because I've, like, yeah, we're gonna try 26 TRCD and TRP. So on Intel, TRCD and TRP are linked, so you have to run them at the same setting. I mean, if you don't set them to the same setting, one of them takes priority over the other, but I'm not sure which one. So it's best that you set them both to the same setting so that you're not wondering, like, oh, which one's actually the one being applied. So, and actually before we go up to 3600, I want to check that this still works at 3466, because sometimes when you loosen out the timings, the things get worse. So we're going to check this at 3466, and then we're going to go up to 3600, and then it'll probably stop posting again. Okay, that still works. Now we're going to go up to 3600. And... okay, no, it's just not going to do 3600. Well, that's really disappointing. Yeah, that's extremely disappointing, to be completely honest. So the funny thing is, like, I still technically would need to test this kit on, like, Ryzen to make sure, like, because sometimes, or, well, yeah, I'd still want to test this on Ryzen just in case it's, like, a Intel memory controller thing. Because there's certain memory chips that run way better on AMD than they run on Intel, and the opposite is also true, where some chips run way better on Intel than they run on AMD. Also, I didn't clear the BIOS, I just restarted. Wait. Nope. I'm just going to hard shut down. Clear Cmos. And we're going to see what kind of settings we can run at 3466. Yeah, I'm pretty disappointed though. Unless it does like CL12 or something at 1.4 volts, which I don't think is very likely. F2. So we're just going to go straight to 3466, and I'm going to try it with... You know what, we're going to go up to 1.5 volts this time. Right, like if it stops working, then we've learned some new information. We've learned something, and if it keeps working, then it's great. So we're gonna go to that. Hopefully that works. Okay, no, it's upset again. Man, this stuff sucks. Oh yeah, this really sucks. Because there are certain 4 GB memory sticks that, like, they're going to be rated at like 2400, and well, there are 4 gigabit memory chips that pretty much regardless of their spec will do over 4000. And then there's stuff like this, which actually, like, that's the thing, is a lot of the 2400, like, with the really low speed bins, it really depends on which exact memory chip you get. Because some chips, they just overclock like crazy, and then there's other chips that behave like this, which, yeah, this isn't great. This really isn't great at all. 1.4. Does it need like 18, 18, 18? Actually, let's try 20 first. With 40 for that. Okay, I think that worked. Right? Yeah. Okay, well, that worked. Kind of wondering if there's anything that, like, the board might be doing wrong. Actually, I have an idea. I want to try something out. For high frequency. I'm going to try 48, 44 on these. Or actually, like, I'm just going to send all of these timings to straight to hell, basically. So this is awful for performance, what I just did. But what, like, the thing is I've run into this with other Micron memory chips where they just won't boot until you loosen out the tertiaries like crazy. So I'm kind of hoping that maybe that's the issue with this for doing 3600. No, that's not the issue. 3600 is just not happening. Yeah. Oh well, that's really disappointing. So I guess we'll just see what I can do at 3466 with these. But the fact that, like, they don't even do CL16. Or, well, I don't know that they don't do 16, but the TRCD requirement is already really, really high at 3466, evidently, but... Like, I'd rather have high CAS latency and low TRCD than high TRCD and low CAS latency, because TRCD actually has more of an effect on performance, but... Anyway, so we're going to try 18, 18, 18, 36. Leave everything else auto. 1.4 volts. Okay, no, it's TRCD. I won't do 18 TRCD. That's really bad. Like, you can get CJR in 16, 18, 18, and this won't do 16, 18, 18. At 3466. still, definitely need to still test it on Ryzen just to see if, like, just in case it doesn't clock higher, but... Because the funny thing is, I've had similar experience with, say, Z390 and Micron Revision E memory chips, where on certain Z390 boards, like, Revision E just walls at, like, 3600, because there's some kind of configuration issue that I don't know how to fix. So yeah, in that scenario, it's just like, yeah, so, and then if you take those exact same memory sticks and put them onto like an X570 board or a Z490 board, you can go way over 4000, no problem. So there's a chance that this board just doesn't support these memory chips like at all, and so this walls at 3466. But, yeah, no, I'm not impressed. I'm very not impressed. Let's go to 1.4 again. Try 1620. Which, that's really bad. That's awful. And we're going to try that. Okay, I think that worked. Like, because when the LED flickers back and forth, over and over, that's like it's not working, but when it doesn't do the fast flickering, then it's like, okay, it actually seems to be working. Actually, I want to check something. PC health status. VCCSA, yeah, so the system agent readout in the tweaker tab is not accurate, because if you go to, like, if we go to settings PC health status, you can see that VCCSA is at 1.33, and in the tweaker tab, it says 1.05, but that's because auto doesn't mean auto. Like, auto doesn't mean stock. Auto means motherboard defined limit, so we're going to set that to, like, 1.2, because at this kind of frequency, you don't need 1.3 volt system agent. What next? I kind of want to see how low we can push the TRFC. Like, maybe, maybe we can compensate for the god-awful timings with, like, really low TRFC. Maybe cast latency can go pretty low. Let's try that. Yeah, and so now we get into the, like, brute force part of memory overclocking, because there's literally no way for me to tell what timings are and aren't going to work until you try them, basically. Okay, so 14, okay, 14, not bad, especially for 1.4 volts, that's, like, not completely terrible. Except it's unstable, so it it crashed right after startup. So, we probably need a bit more memory voltage, or maybe a bit less, depending on, if this memory chip likes voltage or doesn't like voltage, but kind of hoping that it likes it. Okay, I'm hoping that this time it'll make it all the way into the BIOS, but I don't have high hopes for that. Yeah, no, this time it crashed even harder. Okay, well, we're just going to have to clear and then try 1.5 volt CL14. Am I right? 14, 19, 19 or something, which... I don't know. Like, it's not... Like, on what... Because I feel like I'm really biased for anything that doesn't hit... Like, anything that doesn't hit 3600 in my eyes is kind of like, well, that's just terrible. Because most of what I work with these days, like, most of the RAM, most of the RAM that I overclock, I aim for over 4000. Right, and then there's this stuff where it's just like, yeah, 3600 isn't happening. And I still think that might be a compatibility thing. It really wouldn't surprise me, because this memory kit is from, like, 2017. You could tell from the serial number that this is a 2017 kit. And it's just like, yeah, so this thing's way too old to work well on a Z490 board. Or more like, it's way too old for anybody to actually care about high frequency support on a memory kit like this. So now we're going to try with 1.5 volts. Hopefully 14 works. Might even do TRCD 19, which I haven't tried. Let's try that. No, not 63, I said 19. We're gonna, let's try 38. Well, I think that worked. I hate how long it takes for this to, yeah, okay. And it did not crash this time. So, okay, it seems to scale with voltage quite well. Or, like, cast latency seems to scale with voltage a bit. I don't think TRCD does. TRCD generally, like, with the exception of Samsung BDI, TRCD does not scale with voltage. This is like, that timing is in lockstep with frequency. And sometimes it scales with temperature, but most of the time it doesn't scale at all. So TRFC defaults to 450. This is a 4 gigabit memory chip, so by JEDEC spec, it should actually run lower TRFC than your 8 gigabit, 16 gigabit memory chips. So we're going to see if we can run 300, which a 3466 isn't great, but... well, it's not, like, for 3466, that's like, eh. Like, 200 would be great. 300's just kind of eh. It's not bad. Honestly, a dual rank setup of this might not be too bad. Like, if you had four of these sticks, it would still, like, you'd only have 16 gigs of RAM in total, but... yeah, the thing is with these, like, low capacity sticks these days, it's kind of like, unless it does, like, unless you're planning to use it for memory frequency validations, it's honestly kind of pointless. Right? Like, if it doesn't clock super... Because 8 gigs of RAM is not enough RAM. Like, well, I guess it kind of depends on what you use your computer for. But generally, if you have a 10700K, 8 gigs of RAM is not enough RAM. So, let's try 240. Actually, let's try 250. There. I'm going to go in 50 clock steps. And it does 200, I'll be impressed. Oh, no. No, it won't do 200. It doesn't want to do 250. Yeah, no. Okay, so 300 TRFC was actually pretty close to correct right off the bat. My disappointment increases. I really hope this, like, clocks better on Ryzen, or otherwise this is just, like, the most pointless memory kit I've ever bought. Like, if it like, that's the thing, it's an 8 gig kit. Like, it's just kind of pointless unless it can hit high clocks. Right, because, like, because you can run benchmarks on 8 gigs of RAM just fine. Hell, you can run benchmarks on 4 gigs of RAM just fine. Depending on which exact benchmark we're talking about. So as a low capacity, high frequency a low capacity kit that does really good settings for benchmarking is actually great, because they're like, the low capacity makes it cheaper. And you don't care, right? Like, you're not gonna, like, normally if you're running Samsung BDI, which comes in 8 gig sticks, like, you're restricting them to 4 gigs of RAM or 2 gigs of RAM anyway in order to get stability. And so it's just kind of like, yeah, having extra memory capacity on a benchmarking kit is kind of completely irrelevant. So, but this isn't even good for benchmarking because the timings suck. So... If it or frequency validations, right? If this could do like 5 gigahertz, then it would be kind of cool, but we're not even close to 5 gigahertz. So I'm kind of hoping that maybe on Ryzen it would be better for frequency, but yeah, on Intel it doesn't seem to want to go very high. Let's see, 10. Now I'm just going to punch in a bunch of timings that are ill-advised, but hopefully will work. Yeah, this is totally a sense. No, we're going to skip that one. Because, yeah, we're on Intel, so we don't need to set those. 300 TRFC, we're going to set 16 TFAW, TRTP8, command rate. I wonder if it'll do 1-tick command rate. It might. TREFI, we're just going to max TREFI right out. Yep. That should totally work. Like, if this doesn't boot, I won't be very surprised at all. Well, Did I set the voltage? I did not set the voltage. Okay, so we're going to punch in 1.5, and then we're going to run a Geekbench and see what it does. Actually, for Geekbench, we would want to OC the CPU a bit. So CPU clock, we're going to go to 5 gigahertz. Just going to go to override vCore, and I'm going to go with 1.32. That should be plenty for just Geekbench. Going to go 45 on the ring ratio, and we're going to disable the power savings. So we might need a bit of VCCIO. The CPU's not great in terms of ring ratio, so... turbo power limits, disable, C-states, disable, and we're going to disable EIEST. I think that's everything. Also, at this point, I'll actually save a profile, so we're going to save... there. That's a totally good profile name. So if it doesn't post, because I just changed all of the timings at the same time, I don't have to, like, redo all the timings again, or all of the settings again, but I think... The funny thing is, most of the timings that I just punched in settings that look like, where did you get those builds, Zoid? It's, those are, like, BDI timings. Like, TRRD specifically, I've not yet run into a memory chip that, at least for benchmarking, not for full stability, it's different, but TRRD timings, for benchmarking purposes, you can set them 4.416. It doesn't matter at all. You just... I've not run into a chip where that doesn't work. I've run into motherboards where you have compatibility issues, if like where the motherboard behaves weird if you set them 4.416. But I've not run into a memory chip where that doesn't work. And also this does cast latency 1, which, I mean, it does command rate 1, which, you know, that's pretty decent. 1T command rate. That's, like... The funny thing is 1T command rate works just fine until about 3600 basically always. So it's not really much of an achievement, but it's something. Like basically I'd be really disappointed if 1T command rate didn't work right now. But hey, like I'll take anything at this point considering that, yeah. And CPU's at 5 gigahertz. Okay, let's run Geekbench. 7,000 is my guess for the memory score. We should also do a run at XMP just to see how much the performance improved. The thing is, though, is just like nobody's actually realistically going to use a 2x4 memory kit. Unless you're doing like a super cheap APU build or something. In which case, this might if you're doing a super budget APU build, then yeah, you want a 2x4 memory kit. That's just kind of what you want. But yeah, for like benchmarking, this is pointless unless it's no. Even if it's scaled with voltage, like you're not gonna fix the TRCD. Right, like it's a TRCD 19, like that sucks. And it's not gonna, on Intel, it's evidently not gonna go higher frequency. Maybe on a different, maybe an MSI motherboard, maybe a Asus motherboard, it might work a little bit better. Because the funny thing, so on AMD motherboards, the memory compatibility is really consistent basically across all the motherboard vendors because AMD just is really strict about what you can adjust. Yeah, that's kind of, that's just straight up disappointing right there. But, on Intel motherboards, the memory vendor, like the motherboard vendors, actually have a lot of control over the memory controller settings. So on Intel motherboards, the memory compatibility is very different between different boards, like very, very different. So they're all going to be like Z490 boards, but with certain memory sticks, one board will be way better than another board. And I want Asrock timing configurator. We could probably tighten this up. Yeah, this could go lower. That can probably go lower. These might go lower. This might go lower. The DR and DD timings, like this timing and this timing, those don't matter because that is, the DR stands for different rank and DD stands for different dim, right? And so we're in a 1 DIMM per channel, 1 rank per channel configuration, so the DR and DD timings are completely irrelevant here. Yeah, we could definitely tighten this up. This is really loose, 17.9. So we wouldn't actually change these. We would change these down here. So I think WTR, you're probably it can probably run 8.4. So yeah, we're going to go fix those. So I'm going to tighten up the tertiary. So we got under 7,000. I believe I can get 7,000 out of this kit at 1.5 volts. But yeah, so far, like with this motherboard specifically, this kit does. I mean, it's still like a, what is it? Like we're almost a 50% overclock, right? Because it's stock at 2400, but I was hoping for 100%. I was really hoping to get 4800 out of this kit. And you might be like, but Buildzoy, that's really optimistic. There's kits that'll do that. So it's not like I didn't have a reason to think that that might be possible. But at the same time, I'm not surprised that it doesn't work. So we're going to try 6.4. At this lower frequency, I'd hope that that works. So this is at 17, so minus 10 would be... That would be 28. This was at 28, 24. We're going to try that. If that boots, it should be a lot faster. It's not going to boot. Okay, well, it doesn't like that. Luckily, we have a profile. I'm gonna get 7K out of this kit. Like, I'm getting 7K out of this kit. I believe it can do 7K. This time, I'm not gonna punch in the 6.4 settings. Like, I'm not gonna change all of the SG and DG timings, because I think that screwed it over. Okay, we're going to load our profile. Oh, we also have last known good. So last known good, sometimes if that worked, yeah, so last known good is a... I wouldn't rely on last known good, but basically if you're not regularly saving your profiles, the last known good function in Gigabyte BIOSes can be very helpful. It's just not super reliable. Like sometimes it doesn't pull up the settings you thought it should pull. Like the settings you'd expect it to pull up, it doesn't always pull them up. Well... Let's see, so we're going to leave that alone, but we're going to go 10, 10, and 28, 24. Okay, nope. That does not work. Well, okay then. We're going to try the XMP performance and see how much I improve the performance of the kit. But, yeah, I'm really disappointed. Because the thing, I was actually searching for a Samsung 4GB eDie kit in this speed. And they do exist. Those do exist, but they're really, really rare. Whereas the 3.22 kits, well, they're pretty common. But yeah, if this was a version 4.24 instead of a version 3.22... I would be very surprised if it didn't do 4800. So I was really excited that I finally found a 4.24 kit, and then it's like, nope, it's a 3.22, and the compatibility on Intel sucks. Well, we'll see if this goes any better on AMD. It might. It might, but yeah, I don't have very... So like last known good... Oh, it still worked. Lovely. I wouldn't rely on it too much, though. And I didn't even want to use that anyway. Well, we're going to do... Wait, can I just punch an A? Oh, lovely. So we're going to go memory channels. And we're just going to set everything back to auto. And I'm going to enable the XMP and we're going to see how it performs. I think auto is supposed to get like 5K Geekbench or something. So way, way, way worse than the performance I got out of it. But yeah, I mean, it's 2400 CL14K. What do you expect? And now we're just going to enable the Xmp profile and benchmark it with Xmp. I really hope it does better on Ryzen. Like, it was a really cheap kit, but I was really certain. Like, the thing is, I was also considering just buying like OEM sticks, but those are kind of annoying to. Well, those are like not. Well, actually, I don't think you can even buy Samsung eDie in OEM anymore. So, yeah, that's not really an option. Also, before we run the test, I do want to check that the settings are actually applied correctly. So we're going to pull up CPU-Z again. Where is CPU-Z? Memory, yeah, so we're at 2400 CL14. Hey, we had like the same, actually we had better TRFC with my 3466 overclock, so we'll see how this goes. Pretty badly, probably. But that's the thing, so I guess the main takeaway here is even if your memory kit is 2400 CL14, and even if you have no idea what memory chips it comes with, it can still overclock, like, a lot. Just not, like, enough for Buildzoid standards. Seriously, my expectations are way too high. It's like, yeah, this 2400 kit didn't do twice its rated frequency. I'm disappointed. The thing is, I do actually have a stick that's 2400 that does 4800. It's not very stable at that point, but it boots. And the thing is, like, I really wanted I wanted that stick, but with, like, a better PCB and not green. But mostly the better PCB. I wanted that memory chip on an A2. Oh, whoa, it's actually even worse than 5000. So, you know, I managed to squeeze out, what was it, 6600, like 6600-ish. Let's take a look at that. Why is this? We're going to go scientific. Doing very science things. So I was getting like 6600 or something. You can go back in the video and like fact check me if you think that I'm misremembering the numbers. So yeah, 42% increase in memory performance. Not bad considering. Actually, I think that might be in line with the. Yeah, that's roughly in line with the memory frequency increase. Which, yeah, that's kind of what you'd expect, isn't it? Yeah, so actually, let's check Typhoon Burner. If it can't pull up which memory chips it is. The thing is, Typhoon Burner... What? What do you mean you can't find anything? Oh, I think I might have SPD read-write disabled. Well, that sucks. Anyway, so that's it. That's it for the video. But yeah, like, if you were ever wondering if a 2400 CL16 or, well, 2400 rated memory kit can overclock, yes, it can. Just, like... Well, honestly, like, you know, if you're trying to... The thing is, it's just, like, it's going to be all over the place. Because, really, depending on which version number this came with, it could have been, like, drastically better or drastically worse. Right, so this is version 3.22. So if you have well, I mean, you probably don't have this because it's a 4 gig stick, but actually you could technically have an 8 gig stick that's version 3.22. And that might be like, and if it's rated at 2400 and it's a 3.22, you know, 8 gig stick, then yeah, you could probably do 3600, like 3200 CL16 should be easy. 3466 CL16 should also be still easy. You're just not going to be able to run very low TRCD. You should be able to hit reasonably low TRFC. TRDs can probably go, like, hit the floor. If you're on Intel, you're probably not going to be able to run the... I don't remember the names of all the tertiaries, but the big ones, you know, the one that was like 35 and the other one that was 27. Or was it 27? I think it was 27. Yeah, so you're not going to be able to run those two very low, but other than that, like... and actually, if you had this as 8 gig sticks, the stock performance would be quite a bit better just because it would be dual rank instead of single rank, but... Yeah, this was pretty pointless, but even 2400, like, it's overclockable. Like, yeah, and with 1.5 volts, I would totally daily this at 1.5 volts. I don't see a reason not to do that with a kit like this. There are certain memory chips where if you shove 1.5 volts into them, they're not even going to boot at like high frequencies. They're going to just stop work. Like, they're not going to post anymore. But this evidently doesn't really care very much. I'm going to do further testing with this, but on AMD, because it might be the motherboard or the CPU that just doesn't like these sticks, so it's a good idea to check if they don't do any better on AMD. But yeah, right now they're doing, like, they're not doing great on this setup here right now. So yeah, anyway, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. And yeah, both of those help out immensely with running the channel because they allow me to do things like buy questionable quality memory sticks off of eBay. So yeah, that's it for the video. Thanks for watching, and goodbye.